Hello friends, now let's start with the continuation of our previous lecture, that is Java interfaces. So whenever we are working with the HDFS file system, we need different interfaces for working with different types of implementation and different types of interaction with the HDFS. So as I have already told you about the Java interface, so Java interface makes use of the distributed file system class for interaction with the HDFS, and the file system class is used for the implementation of our Java interface. So let's see how exactly this is going to work with the Hadoop file system on standard output using a URLStreamHandler class. Now let us see how exactly this works. So we are making use of a class called as URLCat, which is a public in nature. Then we are making use of a URL dot set URL stream handler factory new FS URL stream handler factory. So this is a function where we are trying to make use of the file system URL stream handler factory. That is, whenever a stream comes from the HDFS, that should be handled by this particular function, and this function notably it is static in nature because we need to use it every time whenever we want to work with it. So here we can see the parameter is FS URL stream handler factory, which is given in the form of a URL. Then we are making use of a function that is stream set URL stream handler factory. So we are setting the URL. Now we are going to the main function, which throws the exception, general type of exception, and here we are using the input stream which comes from the java.io files. Then it is been set to null. Then we are making use of the input is being saved with the URL args of 0, that is whatever we give as the command and argument, that will be taken care of by this particular argument. And we are opening the stream by making use of this URL. So the stream, whatever is being given in the form of the URL address, whatever I have given in the form of a command and argument, will be saved inside the in object. Now I will be making use of this in object and copying the bytes to IO utils, that is IO utilities. So this is where I will be trying to display the files from the Hadoop file system on a standard output using URLStreamHandler. So if I need to print this, then I will be just making use of IO utils and I will be printing the same. So when I try to make use of this particular program and run it inside the Java IDE or Java interface, then I will be getting the output something like this. So we are using export Hadoop class path equals to Hadoop examples.jar, which is the jar file used for working with the Hadoop programs. Then we are trying to make use of the Hadoop command, which is a command line user interface, and we are using URLCat, which is our class name, and this is the URL what I am trying to give. So congul.text. So localhost means we are making use of the HDFS file system, and for that we are using the localhost. So inside that we have user tom and congul.txt, and this is the file what we are going to retrieve when we are running that program inside the command line interface using Java. So similarly we can read the data by making use of the file system API as well. So sometimes it is impossible to set a URL stream handler factory for our application because it is a command line type of program. So a file system is a general file system API. So the first step is to retrieve an instance of the file system we want to use, then HDFS in this case. Then we are making use of the static factory methods for getting a file system instance. So get function is the overloaded form where this is called as a factory method because many times we are using the same function, sometimes with the configuration, sometimes with the URL, then sometimes with the user as well. So these are the different overloaded forms of factory methods provided by the file system for getting the file system required. So in this case we are using the HDFS file system. Then how to retrieve a local file system instance. So for retrieving a local file system instance, we make use of public static function which is already present. So this is a built-in function. So local file system is the file system present inside local PC, and get local will retrieve me the local things. So in the previous situation we are giving the HDFS file system. In this case we are giving the local file system. So we invoke an open method to get the input stream for the file. So we make use of the open function which retrieves FS, that is file system data input stream, in the form of open function, and open function will make use of the argument in the form of path and the buffer size. So sometimes only path can be given, and sometimes we can give even the buffer size. So this is used to open the input stream provided by the HDFS or the local stream. Now displaying files from the Hadoop file system on standard output by using the file system directly. So let us use this program now. This is also a program which is run in the DOS prompt or command prompt. So here we are using the file name as class name as file system cat. Then we are using the main function, and inside this we are using one URI which is read by making use of the command line arguments. Then we are making use of the configuration element, and the configuration is retrieved by making use of file system fs here file system.get, which is a factory method, and here I am using the URI along with the configuration whatever I have created. Then this I am making use of the input stream which is coming from java.io package. Then I am making use of the open function with the URI whatever I have used here. So the URI is given as the command line argument, and that URI is used for opening the file system fs, and by using after making use of this file system pointer, I am making use of the file system pointer along with the function so that it is stored inside the in function. Then in the IO utilities, what I'll do is I just copy the bytes into system.out. So system.out is the default output of our system, and 4096 is the offset given for our output. Then we are setting this to false because we don't want any other outputs to be there, so we are just making use of false here. So we are providing the in object for the output here. So we are copying the bytes to output of our system, and finally whatever IO utils I have used, I will be closing the stream. So normally when we are making use of the data input stream or buffer reader and everything, we will be having the limitation, but when we are using IO utils, then automatically we can see that there is a lot of scope for working with the streams. So data input stream, buffer reader, they work well with the streams, but small streams. But when we are talking about the big data, then we need a very large class which is able to handle that, and IO utils is the definitely a best one which is used for handling the larger streams. So the program when we are running, then we are getting it something like this. So Hadoop is our command, and file system cat is our file name, and this is the URI whatever I am giving, and this is the output whatever we are getting. Now let's make use of file system data input stream. The open method on file system actually returns a file system data input stream rather than java.io class. As I have already told you, data input stream or buffer reader belong to java.io, so on the FS data input stream doesn't belong to java.io class. Now when we are making use of this FS data input stream, we are also able to make use of the random access to our file system. So in the random access of our file system, we can see that we can jump to any part of the file. So normally in file system, we make use of the skip function present inside java.io.file system, but when we are making use of FS data input stream, we make use of something called as positioned readable type of seekable and position readable type of interfaces which are implemented by FS data input stream. So FS data input stream is the inherited class of the data input stream. So data input stream is a normal java.io class, and inherited class of data input stream here is FS data input stream. So let us see what is the seekable interface having inside it. So in the seekable interface we have a function called as seek, which makes use of the position. Then we have a long, which gets the position. So seek is used for positioning of a file anywhere inside the program by giving the number of bytes present inside that file, and get position gives us the current position of the particular cursor wherever we are present inside our HDFS file. So both of these throw the IO exception. So displaying the files from Hadoop file system on standard output device by using seek. So let us use that seek as the example for this particular program. So we are making is a file system doublecat as a class name, and we are using main function here, and we are using URI as we have done earlier, and we are using configuration here, and we are using a file system object, and we are using URI.create configuration. Then FSDataInputStream equals to null, that is in object equals to null. Then I am making use of fs.open and open the path, whatever is there. I am opening the file system pointer by making use of the file open. Then I am making use of IO-utils.copy bytes to system.out 4096 false. So this is given to your output of our default output to the screen. And here I am making use of in.seek, which takes the cursor position in our file to the starting of the file by making use of in.seek0. So we can give any position here. I have just used 0 here. So I will be using io.utils copy bytes, and I am trying to print the things once again by making use of the things to output. So finally I will be closing the string. Now let's see what happens in the output. So here we can see we are using Hadoop file system doublecat. Then I am giving the URI in the form of HDFS localhost user tom.congle.txt, and here we are having the output. So on the top of Crumpty tree to beaver hat. So this was before this particular statement. So this was before this statement. So till here we have printed the things, and as soon as I make use of the seek equals to 0, then it goes back to the initial condition or the initial position and makes use of the initial position here and prints the same thing once again. So similarly we can make use of some other functions which implements position readable interface for reading parts of a file at a given offset. So here we are providing buffer with respect to offset as well as length of the file. So all of these can be given, and we are using the functions called as read for position readable, then read fully. Both are overloaded forms. So here we can see we are using byte buffer. Here also we use the same things. Then these things can be used for reading the files. So let us see the highlights of this particular presentation. So first we saw how exactly our file system Java interface uses a distributed file system and file system. Then we are making use of the URLStreamHandler factory here in this case, and every time we are making the input stream object in, and to write the stream to the output we are using io-utils.copy. Then the same thing we are trying to read the things by making use of the file system API. In the previous situation we used URLStreamHandler. In this case we are using file system API, which is having get function in different overloaded forms. Then we have the open method to open the file, to open the stream of the file. Then we are making use of the FSDataInputStream, and we are using the seek and the positionable interfaces, and seekable interface makes use of the seek and get position, and we are displaying the things. And we also have position readable interface, which can also be used for reading the output from the HDFS. Okay, we'll see the writing of data into the HDFS in our next presentation.